Hi, hello. This is Kiran Jyoti. I have completed my MSc Mathematics and having an experience of 8 years as a mathematics tutor. And right now I'm working for MulteArts Private Limited. So today's my topic is trigonometry. So usually trigonometry, it deals with the subject of it deals with the right angles and sides of angles of a right angle triangle. So usually we'll be dealing with the right angle triangles in trigonometry. So suppose that this is a right angle triangle ABC, and our right angle is measured at angle B. That is, it measures angle of 90 degrees. That is, angle B would be 90 degrees. So this is called the perpendicular, and A would be our acute angle. So here, trigonometric ratios can be always defined with respect to the acute angle A. Why? Because it is called an acute angle. Here already angle B is measuring 90 degrees, and some of the angles of a triangle, as we know that it is angle A plus angle B plus angle C equal to 180 degrees. Already angle B is measuring 90 degrees. So obviously these two angles will be angle C and angle B should be, sum of these two angles should be 90 degrees. So obviously it should be the less than 90 degrees. So this is an acute angle A. So these trigonometric ratios can be defined with respect to this acute angle A. Now I'm going to define you the trigonometric ratios with respect to A. So here the side which is opposite to acute angle is known as perpendicular, because we can see that this is making a right angle triangle. We call this side as perpendicular. We call this as a perpendicular. And usually in triangle ABC, this is known as base. As we all know that this is the base. So AB is known as the base. And the longest side of this triangle is known as hypotenuse. So AC would be called as hypotenuse, which is also known as the longest side. And in general language of this trigonometry, we call this perpendicular side also as opposite side, because the side is which is opposite to acute angle is also known as the opposite side. This is called opposite side, and the side which is adjacent to this acute angle A is also known as adjacent side. So usually we'll be calling opposite side, adjacent side, and hypotenuse. So AB is also known as the adjacent side. And the longest side is already I noticed as this as hypotenuse. Now I'm going to define the trigonometric ratios depending upon this opposite, adjacent, and hypotenuse. So I'm going to write down the trigonometric ratios now with respect to angle, acute angle A. So sine A is defined as opposite side by hypotenuse. Opposite side by hypotenuse. Okay, so this by that is opposite side is here BC and your hypotenuse is AC. So sine A is defined as BC by AC. Now I'm going to define cos A. Cos A will be defined as adjacent side, that is AB, adjacent side by hypotenuse, that is AB by AC. So cos A is known as adjacent side by hypotenuse, which is equal to AB by AC. And similarly, we can define tan A also here. Tan A will be written as, I'm writing upwards, tan A will be equal to opposite side by adjacent side. Opposite side by adjacent side, that is BC by AB. Okay. And similarly, we can take the reciprocals of this, that is sine, cos, and tan. That is, first cosecant A can be written as 1 by sine A, and cos A can be written as 1 by secant A, and tan A can also be written as 1 by cot A, which I'll show you in the next step. So these are the trigonometric ratios now. I'm going to define you the relationship between trigonometric ratios. that is sin theta can be written as 1 by cosecant theta. Okay, sin can also be written as reciprocal of cosecant theta, and cos theta can be written as reciprocal of secant theta. That is, cos theta can be defined as 1 by secant theta, and tan theta can be defined as reciprocal of cot theta, that is 1 by cot theta, and tan theta can also be defined as sin by cos. Okay, so tan theta can be written as sin theta by cos theta, and cot theta can be written as 1 by tan theta. That means cot theta is nothing but this is reciprocal of our tan theta, which can also be written as cos by sin. Cos theta by sin theta. And from this we can evaluate one identity, that is sin theta equal to 1 by cosecant theta we have written. From this we can evaluate that sin theta into cosecant theta, this into this will be equal to 1. So sin theta into cosecant theta equal to 1. Okay, and similarly cos theta into secant theta also can be written as 1. Cos theta into cosecant theta, cos theta into secant theta equal to 1, and here also tan theta into cot theta equal to 1. So this is how we can define the relationship between the trigonometric ratios. Now I am going to explain you some few identities which are very important in trigonometry. So we have an important identities which are very useful in our problems here. I am writing trigonometric identities, which will be useful in our problems mostly. Okay. So the trigonometric identities, we have three here, that is sin square theta plus cos square theta equal to 1. First one is sin square theta plus cos square theta equal to 1. Okay. And the second most is secant square theta minus tan square theta equal to 1. And the next one is cosecant square theta minus cot square theta equal to 1. So these are the main trigonometric identities which are very helpful in our problems. Okay. And here from secant square minus tan square we can evaluate one more, that is secant square theta can be written as 1 plus tan square, because minus tan square theta, if it goes to right hand side, minus will become plus. So secant square theta can be written as 1 plus tan square theta. And similarly, we can evaluate the tan will be 1 plus secant square. And here also cosecant square theta will be equal to 1 plus cot square theta. So these three identities are very essential for us in problems. Now I'm going to explain you the trigonometric identities related to few angles. Okay. So I'm going to define that now. Suppose that we have sin theta, cos theta, tan theta, these three, and the angles are now, suppose that sin 0 is there. Sin 0 value would be always 0. Okay, sin 0 equal to 0, and sin 90 is equal to 1. Okay, and next one would be sin 30. Sin 30 and cos 60 always, sin 30 degrees and cos 60 will be always same, that is the value will be always half, that is 1 by 2. And next one will be sin 60 and cos 30, which is equal to the value of sin 60 degrees and cos 30 degrees will be root 3 by 2. And the next one will be sin 45 degrees and cos 45 will be always same, that is 1 by root 2. We can also make these angles values as a tabular format, but this would be very easy for us to remember, so that I'm writing together like sin 30 cos 60 is 1 by 2. So together I'm making it as equal to 1 by 2. And similarly sin 60 cos 30 value is also same, that is root 3 by 2. And sin 45 cos 45, both the values are 1 by root 2, which is equal. And now we are going to take down tan values, that is tan 30. Tan 30 is equal to 1 by root 3. Okay. And tan 60 value is It is just root 3. We can easily remember that tan 30 is 1 by root 3. So tan 60 will be reciprocal of this. This root 3 will go up. So tan 60 will equal to root 3. And tan 45, easily we can remember that tan 45 is 1. Okay, so these are the values related to tan, and tan 90 is always undefined. Tan 90 degrees equal to undefined, and tan 0 will be 0. And here first I have written the sine 0, 0, sine 91. Similarly, we can make cos 0 as ulta of this. That is cos 0 will be 1 and cos 90 will be 0. So you can remember easily like this 1, 0, 0, 1, like, okay, and the related values will be like this. Now we are going to see some few example problems related to this trigonometric ratios. Suppose that we have given sine theta equal to 3 by 4. If sine theta equal to 3 by 4, find other trigonometric ratios. Find other trigonometric ratios. So here the value of sine theta is given as 3 by 4. As I said just before that, using the diagram, we can easily find out that suppose that it is acute angle A, right angle is at B, and this is angle C. So sine theta is given as 3 by 4. As I said before that sine theta equal to opposite by hypotenuse, right? Opposite by hypotenuse. I said that this is our opposite side, this is our adjacent side, and this is going to be our hypotenuse, right? So already we know that sine theta is equal to opposite by hypotenuse. Opposite is 3. Okay. So, and 4 will be our hypotenuse. Now we can easily find out what is adjacent side, that is AB. So before knowing what is the value of AB, I would like to tell one very important thing, that is Pythagoras Theorem. Pythagoras Theorem is nothing but AC square equal to AB square plus BC square. That is, the square of the third side will be, that is square of hypotenuse is always equal to square of adjacent plus square of opposite. So already we know that AC is equal to 4. So we can write in place of AC 4 whole square. AB is nothing but adjacent, which we doesn't know. We have to find out. So we can replace AB as it is. And BC value is already we know that it is 3. So you can take down here 3 square. 4 square is nothing but it is 16, 1 6 equal to AB square plus 3 square is 9. Now easily we can find out the value of AB square. AB square will be equal to, you can take 9 to left hand side. So plus 9, if it comes to left hand side, it will become minus 9. So 16 minus 9. 16 minus 9 is nothing but it is 7. So AB square value is 7 and your AB value would be square root of 7. So here the value of AB will be now root of 7. Okay. So this is how we can find, if we know the other two sides, easily we can find the value of third side. Now we can find out the easily other trigonometric ratios. That is sin theta, already given in the question. Now we can easily find out cos theta value. As I said, cos theta is nothing but adjacent by hypotenuse. Adjacent value we already found, that is root 7. So root 7 by hypotenuse is 4. So root 7 by 4. So cos theta value is root 7 by 4. And tan theta is nothing but opposite by adjacent. That is 3 by root 7. So when one value is given, easily we can find out the other trigonometric ratios by using Pythagoras theorem, which is very important in trigonometry. Now I'm going to give you one more small question. So now if I they give you if 3 tan theta equal to 4, find cos theta. Find cos theta. Here the question is given as 3 tan theta equal to 4. So from this we can easily pick out tan theta value. Tan theta equal to 3 will go to right hand side. So it will become 4 by 3, right? Tan theta is equal to 4 by 3. And we know that tan theta is equal to opposite by adjacent. That means here opposite value is given as 4 and adjacent value is given as 3. So easily we can find out hypotenuse. That is, suppose that this is right angle triangle ABC. We know opposite and we know adjacent. That is, this is 4 and this is 3. Now we can easily find out hypotenuse, right? So again we are going to use Pythagoras theorem, that is AC square equal to AB square plus BC square. Okay. So this is what AC we have to find out hypotenuse. So keep like that only and just substitute the values of AB and BC which are given already in the question. AB is 3. So 3 square plus BC is 4. So 4 square. So AC square will be equal to 3 square is 9 plus 4 square is 16. So AC square equal to 9 plus 16 is nothing but it is 25. So we know that AC square equal to 25. From this we can write down AC equal to square root of 25. Square root of 25 is nothing but it is 5. So our hypotenuse value is 5. So this is how we can easily find out the third side by using the trigonometric ratios formulas. Okay. So now we have to find the value of cos theta. That is cos theta, we know that adjacent by hypotenuse, which is equal to 3 by 5. So cos theta equal to 3 by 5, which is the required answer. So these are the basics of trigonometry. So if you like my video, please you can approach MulteArts Private Limited. Thank you so much.